Okay, I'm going to go through this process for doing I'm actually going to do the lab for you right here, other than typing this in over the next 10 minutes. But then the reason I'm recording this is so that you could, come back and do that there. I don't know if this room's available during the times that we don't have it scheduled, but if not, that there. So I'm going to close the software here. And the software that we're running is Silicon Labs IDE. There's another version that we can do, but this is the one that I'm most familiar with, and it's the most common one. So Silicon Labs, and I'm going to close this project here and start a new project right here, right there. And we're going to hit a new project. So we had project, and we're going to go through new projects. So we're going to create a new project up there, and you're going to have to work with this side of the room. This side, the left side, does not have the software. So take a chair and partner up with somebody on this side of the room. Out there. Okay. So we're going to create a new project. And I'm going to go through the step-by-step here. New project. The family we're going to be using, and this is important right there, is the, right there, you can see that it's the C8051F850X _860X. And that actually comes from, if you look at this board right here, it's a tool stick platform, but if you look at the board itself, there it says tool stick F85X. Everybody see where it says that on the board? That's telling us that this particular chip is an F850. It's a C8051F850 is what this chip is on here. So we tell it that we're going to there, and then I'm also going to give it a project name, and I'm just going to call this Project MicroP C Lab1, something like that there. I'm just going to call it that there. And I need to make sure I check the right. I lost the chip family here. C850. I lost. Right here it is. Okay. And we're going to, project type is an ASM source file. So this is what you should see, something like this. Now, location, I would recommend that you don't put it in that directory. I would put it someplace where you know where you're going to find it, because you're going to need that for your report. And the desktop, just call it, and I'm going to call it MicroP C Lab1 right there. In other words, put it somewhere where you can find it. You can create a directory. You can put it anywhere, right there. So I'm going to go ahead and put it on the desktop. Now, once I bring that up here, I'm going to there. Here's my source file right here. Oh, that's not the one I want right there. That's the header file right there. Let's close that. We need to create a new file right there. Right there, and we're going to call that the source file, and that's our MicroP C Lab1, and we click add to project right there, and add to build. So we're creating, this is the file that we're going to create. So we're going through the steps right there. So we create that. So okay, right here, and now this is a blank file. Now, I cheated and I cut and pasted from the previous one, so I'm going to go ahead and paste that. So this is the code right here that you need to enter. And in the lab, I got parts of it there's missing parts here. So the first line of this program just simply says no mod 51. So in other words, we're telling the compiler that we're just doing a standard 8051 assembly language right there is what that is. All this copyright stuff you can delete that there. That's simply because I stole the code. I didn't actually type it. What you should put in here, to be honest, is you should put in here, things such as, let's go to hack. Now, comments begin with a semicolon at the beginning of the line. This is Lab1 microprocessors, right there. Something like that, there, right there. Lab1. This is normally where you would put any comments for your code. And those of you that have taken C courses know that you normally would put a header file in there. I don't have any strong restrictions on header files, what they look like. But you should at least have your name and a description what the program does. For sake of time, I'm just going to leave it just as that for right now. But you should have your name, your student number in there, a brief description. This program blinks the light at such and such a frequency that they're on port, whatever, right there. So that's the header. The next line is one that you have to have there, and that for every program that you write in assembly language, and that is our include C8051F850.inc. That's that file I keep talking about that defines what P1 is, P2, and all those out there. So you just include that. You don't have to type that. If you don't include that file, then you can't use things such as P1. You actually have to put 90 down as the port and the bit addresses if you want that there. This actually allows us our code to be much easier. Now, in this particular case, since I stole this code, it says green LED because the board in which this was originally for, that was a green LED and a red LED. Our board just has two red LEDs, so I left it as green LED, and that's on port 1.0, and you could see that by looking at your board right there. The two LEDs are on the bottom, and you can see port 1.0 is the one on the right. Now, as you read the lab, you have to be able to turn both of them on and off. That's there. So you'll be using port 1.1 and that there. You could change that to simply say green LED. I could just simply say white LED. Right LED, right there. Now, again, what we're going to do at this point is the next two lines are used to set up what we want our processor to do when it's reset. When the microprocessor is reset, it automatically goes to code segment location 0.0000. That's our reset vector right there. And what we're going to say is that in our code segment at location 0, we want to put our code when this thing turns on. And when we turn this on, all we want to do is just do a long jump to main. And the reason it's a long jump is because we don't know where the assembler is going to place that. We can actually tell it where we want to place it, but right there. So that's the next step there. And every assembly language program you're going to write is going to have this particular segment of code in there. And this should have been part of you printed out what I posted. This is it. It should be in there, right? All right. Our code segment down here, right here, is that we're going to set up something in our code segment called blink, right there. It's in the code segment, and we're going to set our registers to bank 0. Yeah. Oh. Okay. Oh, you're. Okay. Hold on here. Where are we at? Close that. Close this right here. Close that there. And hit new file right there. No, just new file. And then you want to hit ASM source file right there, and then give it a name. And then add the project and add the build. Yeah, there you go. Okay, I'm sorry. One of the reasons I'm recording this is... Yeah, okay, that's there. Okay. We'll try to keep up at this point. You can type this later. I'll leave this up here. That there. Yeah, that there. Again, you know, like I said, this is recorded, so up there. But I'll leave this up here. Got there. Okay, let me just kind of go through this here, and most of the beginning of this is actually in the printout that in that there. You can actually copy and paste it from the lab if you downloaded the lab from the website there. So, all right, the next series of lines there. All right, let me go back here. Let me start back here again. All right, here, this is our code that you're going to have to enter. And again, the first part of this is actually standard for every program. The first line, just simply, this is just telling the compiler or somewhere that we're using on 8051 without modifications, right there. The next series of lines is actually our header. You know, and these are just comments so that when we look at our code, we know what this program is. And I didn't fill this in. This line here is just telling the compiler or the somewhere that we want to include all the header documentation, all the port definitions. That's there. And then we have what's called the equates. Now, equates are basically anything that we want to name in our code that relates to something physical and hardware normally, or variables or memory locations. That's there. So all we're saying is our right LED is equivalent to port 1.0. I can put another one in here and call it left LED, and I can say that that is equivalent to port 1.1. Right there. So, you know, so those are our two LEDs. Then the next thing is we're going to say that whenever there's a reset, we want to go to jump to main. And this is how we handle this right here. Because when you write C code, that's all done for you. But here we're saying at memory location 0 in the code segment, we want to place the command long jump main. Now when I compile this, you'll see where that's done at there. So now we go through here, and our next thing right here is our actual code. Blank is what we're going to call our code segment right there, and we're using register bank 0. Remember, I said yesterday that we had a choice of 4 register banks, so we're going to use register bank 0. This is where we tell the assembler what set of 8 registers we're going to use. Now, we actually don't use any of them in this particular case. That's there. But we have to specify that. These 2 lines are standard. We'll cover those. These next series of lines we'll cover next week. Or not next week, the week after next. Next week, everyone's going to be, going home, right? Taking a break. Yeah, you're running away from here. That's there. So, but, you know, we're going to disable the watchdog timer. That is done by simply writing 2 commands to it. Right there, the watchdog timer control register. We're going to enable the crossbar right there and turn on the weak pull-ups right there. And we're going to set that there. Now, in this particular case, I set 2 ports there, so I probably would want to change that to 03. I'm going to go ahead and change this to 03 simply because in your lab that you're supposed to do, you're supposed to use both LEDs. So we want P10 and P11 to both have a 1 there. So we do that by just writing a 1 to them. And that sets it up as an output pin with push-pull output right there. So we initialize our green LED to off right there. right there. And then we go through our delay loop, and I talked a little bit about that yesterday, right there. Here's our delay loop. It's 3 nested loops. We load, I think the original one had like 3 in it or something like that. I'm just going to change that to a 3. This is the number that you're going to be playing with a little bit. Right there. Right there. So we move into R7 3. We move into R6 0. We move into R5 0. And these 2 lines here is just this one here is decrement and jump if not 0 back to, and this is a little tricky, it puts a $sign, which means the same location. So this is cheating a little bit. We haven't talked about the $sign, but that just simply means the same location right there. And when I put 0 0 into R5 and we decrement it, that brings it to 255. It starts off as 0 0. We decrement it before we do the compare, so it becomes 255. Then the next time it becomes 254, 253. It keeps counting down until it gets to 0. And when it gets to 0, it comes down to the next line where it decrements R6, which also had a 0 0 in it. And now R6 is now 255, and so it does a jump if not 0 back to loop 0. Well, loop 0 then reloads R5. And so it's going to be doing the inner loop 255 or 256 times, and it's going to do the outer loop 256 times. So every time through that is 256 times 256. Yeah. So we're going 65,000 times we're doing this loop, times 3 clock cycles per iteration, times 3 clock cycles. So we're looking at about 200 clock cycles every time we go through each one of those inner loops right there, those 2 inner loops together. We're looking at 200 clock cycles, or 200,000 clock cycles, and we said that there's 2 billion clock cycles in a in a second coming from the clock. So this is going to blink, if we had a 1 there, about 10 times a second. So if we do it twice, it should blink about twice a second. So but this is where we get our calculation that you need there for the lab write-up, is you look at this loop here between R0 and this here. That's 255 times around that, or excuse me, 256 times here for this loop, this command here, jump not 0. That does that 256 times. And then we then jump here back there and redo it. So we're going to do it 256 times 256 times, right there. And then we jump to the next one where we decrement R7, and we jump back to loop 1, right there. So then we're going to, so in this particular case, I'm going to go about 600 clock cycles is what I'm going to be running at, right there. 600 clock cycles is about 3 times a second. I'll let you do the calculations. That's in the lab on how you do the calculations, but it's roughly 256 times 256 is the number of times. We're estimating 3 machine cycles per instruction. So you're looking at roughly 200,000 instructions per running through that inner loop, right there. That's a big number. And then what we do at the end of that loop is we're just going to complement the green LED, only I changed that to right LED, right? Right. LED. Okay. And then we just jump back to the beginning, and we just do this forever and ever and ever and ever. That's our code. That's your assignment, to do this first, right there. So once we've got this code entered, right there, and I think everything up to here, right there, we're going to go ahead and we're going to rebuild all. And I have an error here. And what is my error? One error. Clear green LED. Oh. Remember, I changed that to right. Right there. So, that there. You see, this tells me that we had an error. If I double click on that, it shows me where the error is. So, that there. So, we just go ahead and recompile that. This time I got 0 warnings. Now, this is the point where we plug our board in. And this is why I keep breaking glasses. So I'm just going to plug my board in here. Right here. Right there. It's plugged in. Both LEDs are on. Right there. I connect it. And this is giving me an error. And the reason it's giving me an error is I have to go to connection options, and I have to change that to C2. But it's not in the lab. That's why I recorded this, so that you could go through as you go through and look at that there. But we have to change that to C2. Right there. Hit OK. Now I can connect. So now we've connected. Now I can download our circuit into the board. Now at this point right here, what I'm going to do is take a little bit of time to break off here. And I want to, under view, I want to look at our code right here. Right there. I want to also debug view, debug windows. This assembly. Okay, this is what I wanted to see over here. Right here. Let me move this over here. This is my, let me close this and let me project view debug windows, and I want to look at the registers right here. So this is this is the code in which it's going to be running. The first thing it's got is a long jump to location 0800 hex. So that's my jump to blank right there. So now I could go through here and I can single step through my code, and I can see what happens here. Single step right here. And notice here that I now jump down here to location 80800. So that's where I'm at in my code right there. And that's our move 97, location 97 DE. If I come back here and look at my main right here, and this is where, you know, I'm sorry to say this, we're at a little bit of a disadvantage here because our screen resolution doesn't let me see the whole window here. But if I look here, you can see here that our next instruction is move to watchdog timer control register DE. Well, over here on our disassembly, we've got move to location 97H DE. If you were to go back and look at the watchdog control register, you'd find that that's memory location 97 in the special function registers. So there's the instruction for that. This is the special instruction, the instruction for the next one. So we can just single step through here, right there. And now we're going to move, our next one is we're going to, again, move 40 into, to our crossbar, register 2, right there. Now we're going to go through and we're going to XOR and you can see our location F2, we're going to XOR it with our 3. So you can see our instructions are being done, you know, as we're going through here, we can see it on both our assembly code that we wrote, and we're following our code here. And clear 90 C2 is the opcode for clear, a memory location. If we were to look up the opcode for clear, it's C2, and 90 is the location. That takes up 2 bytes. That there. And as you recall, I talked about some of these instructions require 2 bytes, some require 3 bytes, some require 1 byte. Right there. This instruction right here, 4.3, requires 2, because we're going to do a logical OR location F2 with the number 3. Right there. So 43 is the opcode for ORL. So we're not covering the opcode, but we can see what they are there. And we can just go through here, and we can single step one line at a time. Now here we're going to move into R703, and if we look here, we can see that R7 now contains 03. We're going to move R6 now contains 0. R5 will contain 0 after that one there, and whatever changes right there. And then I can single step through this here, and you're going to see that this changes every time I push this button. Now I'm going to be here a long time, so I can just hit the green light, and this program just runs freely. And you can see the light blinking right there. So, but this is what I want you to look at today, is to go through and look at this right here. Now, as you read the assignment, I have you put both lights in there, and that's very easy to do. I'm just going to go ahead. I'm not going to let you copy it from me. I'm going to go do it very quickly, but you can see me do it. All it's going to be on the recording, so you can play it back there. But the second part of the last part, I have you. Let me come back here. I have you use the other LED, and I have you switch them back and forth. I already added the other LED, so I already did part of it for you. I added the other LED right here, right there, and down here I cleared it. So then at this particular point, what I want to do is probably just go through here. And I keep it's set byte, as I recall. LED. Let's see if that compiles. Nope. Actually, you know what I'm going to do, since I can't remember, right? I'll clear, and then I'll just complement it. And that's not CPL. CPL. LED. That should be LED. And upper or lowercase doesn't make any difference. I normally like to capitalize left LED. LED. Right there. And then CPL. Left LED. And if I didn't screw it up, and you can see it does what I told you to do. So modification is fairly straightforward, that there. But I'm going to take that out there. It's only about 3 lines of code. Right. Right there. Right there. And now this should just be blank the one LED right there. Back to the original. Now, keep in mind that I can stop this at any point right there, and I can see what the registers are. I can also set breakpoints, but for right now, I'm just going to leave it right there. Where do you want me to leave the screen here? Let me... I think that's probably about as... All right. The rest of the time is yours to do it. Right there. So now I'm done talking. I'm just going to leave this sit there. So, out there. Any questions out there? Now, if you're really quick at typing, you could have kept up with me. You'd be done already. But that was not the intention. The intention is for you to take your time and go through out there. And with that said, we don't have a printer in here, do we? All right, let me